Hello, hello. I think we're going to get started because we're running a few minutes late. Our next speaker is actually Paul Bowser from Roush Industries, and Paul has been for almost 30 years. Paul Bowser has worked at Roush Prototype Group Services and the mobility industry, most tech. And wait a minute. Oh, let me start all over. For almost 30 years, Paul Bowser has worked with Roush Prototype Group to resolve the mobility industry's most technically complex product development challenges. After gaining experience in Roush's electronics and instrumentation group, Paul now serves as the director of the company for garage services, wiring, and electrical teams. This group provides prototype development and system fabrication and short-run manufacturing services to automotive, commercial vehicle, and defense segments, integrating hybrid, electrification, DAT, and ADAS, and autonomous technologies. In addition to leading these technical teams, Paul Bowser works with local post-secondary educational institutions to create training curricula and encourages the growth of our current employees, as well as providing career pathways in the professional trades. Paul is a U.S. Army veteran and plays a key role in Roush's Veterans Initiative program, recruiting veterans and helping to translate their military skills and experiences into civilian work environment. Paul?
Thank you, Ben. Sorry about that long dissertation that Roush sent to you for that. So here to talk to you just a little bit about technician skills gap. We experienced this just a little ahead of what the OEMs and service providers out in the field are experiencing because we're building the prototypes, which are a year to 3 to 4 years ahead of schedule for everybody else to see that same technology. So the technician skills gap is really apparent to our teams early on as new technologies are being released. We got a video.
My name is Dave Myers. I'm a build shop supervisor out of one of our Allen Park facilities. I've been with Roush for roughly 20 years. We're currently looking for mechanical technicians and electrical technicians. Mechanical technicians will help us through the prototype development process. I'll work with many different types of vehicles, all the way to doing tire changes to building one-off vehicles for any one of our customers. Electrical technicians will do the same, more with the electrical side of things, building wiring harnesses, modifying wiring harnesses, instrumentation, things of that sort. With the technology growing in those electrical areas, the battery electric vehicles are, of course, on the forefront of the industry. Next behind it would be the autonomous vehicles and any of the driver assist technology. All of those are breaking through and becoming very popular. The people working in these positions will be working on vehicles that most people haven't even seen. We'll be working on vehicles that probably won't even be seen on the road for another 3 to 4 years. We're working on the stuff that has not been even in the industry in the general public. So I started at Roush when I was 18 years old, started as a mechanical assistant. I worked my way up through different programs, projects, hard work, mentorship within our company. Definitely helped me develop to get where I'm at today. From there, I worked in a coordination position, and then ultimately I'm now in a shop supervisor position. My favorite thing about working at Roush is a mix between the products and the people. Products as far as working on the vehicles that have not been seen by the general public. The people, you really get a sense of innovation, a sense of camaraderie from a lot of people within our company. We work together to develop these great products that we get to ship out the door to our several customers, and we deliver the best quality product that we can in the most time efficient way. So within Roush, we have our own training programs that focus on the electrical side due to the technology moving so quickly. We have classes that basically go from basic electrical all the way through autonomy. It'll show us how battery electric vehicles work, hybrid vehicles, high voltage, along with all the different systems that are involved in the autonomous vehicles. So as a mechanic on the floor at Roush, working with engineers, there's a lot of teamwork that happens. We feed off one another. Both mechanics and engineers feed off the inputs and the outputs from either team. We really develop a lot of collaboration, a lot of great relationships from that. that really build a foundation for us to develop a better quality vehicle for us or our customers. But what keeps me at Roush is really the collaboration. It's really the people. It's the entrepreneurial spirit that we have within our company that allows us the freedom to do everything and anything that we need to develop the best quality product for us or our customers.
All right, so first I'd like to break a couple of paradigms. One of those is that Roush is in Mustangs and NASCAR, and that is about 200 employees out of 5,000. So there are 4,800 employees doing things other than NASCAR and Mustangs. And most of that is prototype development. A large portion of that business is with Ford, but we work with all the OEMs and most any car manufacturer or vehicle manufacturer that has a plant in the United States. From defense to aviation to aeronautics to space, and every ground vehicle that is in existence, we've touched in some way, shape, or form. So the challenges that we have as far as technicians and incoming employees, we've reached out with videos like this one. We've got half a dozen of these things floating around on LinkedIn to try and convince people that this industry is something to strive for. It's something to get into early. We put Dave in this video on purpose because he started with us with absolutely no mechanical skills as an 18-year-old kid. And he's now been with us for 20 years. He's a supervisor of 2 facilities, works under myself, and he's been very successful through mentorship, apprenticeship, learning from that tribal knowledge that floats through our shops. And that's how most of the automotive industry has worked in the past. And now we're starting to try and rely on the post-secondary education to provide our employees with electrical, with IT, with continued mechanical skills and all the new things that are coming about in the industry. So the rest of my slideshow is kind of going to lay out what we've done and the help that we're looking for to continue doing what we do from the educational side of things. So looking at this, we saw a couple of charts early today that demonstrated when decisions were made to go to EV vehicles, when decisions are being made to go to AV vehicles, things like that. And one of those charts demonstrated that there was going to be a big change in 2020 regarding EV vehicles and the development and production of those things. But if you notice our chart, you can see that we've got pretty consistent percentages along the top side on the left under electrified vehicles. But then in 2019, we see a fair jump. And what I want to point out is that in 2019, we went up 23% from ICE engine development to electrified development. We did a shift a year prior to when that was expected in the regular industry. So it's further information that provides that prototype developers and the folks that are in the background for our OEMs building the future vehicles are seeing this technology ahead of time. And to follow on from that, the percentages look like they're a little bit off as you start to look at 2020, right? Because we see a drop in percentage. But go across the slide to the right side, and you'll see that we had 42% electrified and 41% AV. AVs are electrified, they're hybrid. They don't, a standard ICE engine powertrain doesn't produce enough power to enable the AV systems that are in these vehicles drawing hundreds of amps of current. So when we add those together, we've got 82% of our prototype work in 2020 was related to some form of EV, all right? So the shift from ICE to EV and AV has a significant increase in growth paths. The rapid increase in complexity on these vehicles is driving different facets of development, manufacturing that contains high voltage. We know that coming into EV vehicles, we were in the 200 volt range, and current vehicles that are on the road today are in the 400 to 600 volt range. And we've got discussions in the prototype realm of going to 800 and 1,000 volts. So as we continue to increase these voltages that are driving these vehicles, it changes the equipment and the tooling that we're using to build them and test them. So this drives expansion of what we do as a company. Those complex electronics that control all the high voltage remain 12 volts. So we still need the existing 12 volt training, but we have to add the high voltage training to that. Now I'll dial the clock back just a few minutes. When I went through my first EV training, it was provided by DTE, and it was 1998. And they actually brought in a high voltage transformer and demonstrated for us what high voltage would do to you if you short circuited it, right? So fast forward now, we're now in that realm, and we need to actually work on 600, 800, 1,000 volts in a vehicle. So isolation between low voltage and high voltage is important, all done by electronics. So that takes the requirement of a mechanic or even an electrical tech in the automotive realm to now an electronics tech. He needs to understand, how does a transformer work? How does a transistor work? How does a programmable chip work? Moving forward from that, all the communication that happens in these vehicles is high speed. We can't do most of the communication through the standard CAN bus that everybody recognizes in the industry. We're now going to IT networking. We have 40 channel network switches in our AV vehicles to transmit that information on a more rapid pace. And we're now at a point with AV development that the standard network cabling, Cat5 cables, are not fast enough. Cat6 cables are not even fast enough. So we're using conversions now that take Cat6 electrical connections to fiber optics so that we can move that data more quickly and help the vehicle make decisions. So now our technicians that are working on a shop floor that we would have labeled a mechanic now has to be familiar with IT networks, cybersecurity, data buses, diagnostics, and now lightweighted materials. We're not dealing with steel and aluminum in all these vehicles anymore. We're looking at carbon fibers and fiberglasses and all new composite materials that are constructing the actual structure of the vehicle and the A surfaces, the fenders, the doors, things like that. So our need for skilled and trained Autotechs has never been greater than it is today. So expanding again, the ICE engine systems they're generally simplistic compared to the HV high voltage electrification and AV systems that we're dealing with as integrated into vehicles today. Future techs are going to need to be prepared through education, training, and mentorship. And some of the questions, the challenges that we're going to face and are facing now in the prototype realm is battery chemistry. We have to first decide what kind of chemistry this vehicle coming in with, and how do I manage that? How do I handle it? Safety protocols, what goes along with the handling of that battery system? Interface strategies. You know, CAN bus and OBD2 used to be simplistic, right? You just plugged in under the dash, you communicated with it, and you're done. You can't get to a battery control module through a CAN bus. It's a separate communications network. So now we have to establish a new method or a new standard method to communicate with these units. As I stated before, the tools and equipment is going to continually change. I can't use a standard class 1 multimeter anymore from the local hardware store. I have to go to a specific grade, a class 3 meter, to be able to interface with the high voltage, high current. The absence of the diagnostic experience, a lot of mechanics will come to you and say, I'm not comfortable with electrical. I don't want to fool with that. Well, in the future, a mechanic is going to be forced to deal with electrical systems in addition to the mechanical systems that he has to work on. Requirements for more detailed and robust work instruction. As we're troubleshooting a 700 or 800 or 900 volt vehicle, we have to put that troubleshooting in work instructions to work through step by step. How are we going to get the diagnostics complete on this unit without getting anybody hurt, without affecting anything or anyone around this vehicle? And you know, there's another aspect to this that is called isolation. And I'm sorry if I'm getting too technical, but the isolation is holding a barrier between the low voltage system in the vehicle and a high voltage system in a vehicle. They're both DC or direct current, but if we have a barrier breakdown, there's a safety factor involved there. If the high voltage comes in contact with the low voltage, both systems are going to be affected. And of course, when we affect voltage, we're going to create heat. And when we create heat, we get flames. And nobody wants to see that. So these work instructions have to help us avoid those interfaces between low voltage and high voltage. So that will continue to be more and more important, which beyond the mechanical realm is going to drive manufacturing engineering, quality engineering. So we talked about mechanical engineers earlier today and the higher demand for those. But guess what? There's going to be a higher demand for manufacturing and quality engineers as well. So, driven by the industry and their need to integrate cutting-edge technology, Roush had to develop a fast solution. We know that all of our post-secondary education systems will give us a certificate program or a 2-year degree or a 4-year degree. But if I have technology that walks in from a tier 1 supplier on Monday, I need training for my technicians on Tuesday on how to manage that. So we're working with these suppliers and these new technologies to capture what are the safety factors, what are the technicalities of this new system technology, and how do we deal with it as the people that are going to integrate it. And based around that, we've worked through Michigan New Jobs Training Program with Monroe County Community College and several other entities to develop these classes. And we've put in place kind of a fast pace introduction to electrical systems, to advanced diagnostics, to battery electric and autonomous vehicles, as well as IPC, WHMA, that's wiring harness manufacturing. If you are going to manufacture a high voltage wiring harness, there are a lot of different criteria involved in putting that terminal on the end of the wire than there are a 12 volt system. And IPC WHMA is an internationally recognized standard for building wiring harnesses, and it crosses low voltage and high voltage barriers. So the key to our success in managing, keeping our current employees or our incumbents up to speed with all the new technologies has been a 40-hour approach. We put classes together that we can present in a 50-50 classroom and hands-on environment that gives them enough knowledge to be comfortable that I can now understand what the technology is, I can interact with it enough, and I can learn as I go as an on-the-job training. So as we continue that, ASE is obviously recognizing that this change is inherent. It's going to happen, and they've added in just the last 2 years the L3 exam and the L4 exam. So the L3 is low voltage, light duty, hybrid electric vehicles. And now the L4 is directly related to ADAS, or advanced drive assist systems. So these are all the things that are the new fancy technologies that are in your vehicle, the lane keeping capability, the pre-collision warnings, cross-traffic alerts, your standard reactive cruise control, things like that. But because most of these training programs require some form of a stackable credential, we're relying on a couple of these ASE certifications to give us that stackable credential. Once we've provided training to the technician, they can now go out and take these 2 tests. They have their credential, they got the education from us and through the MNJT program, so that keeps us qualified. So what does that new hiring process look like? Just for Roush, and I stated previously that we're roughly 5,000 employees. Between now and 2026, we're looking at hiring another 500 employees just to keep pace with what the industry is doing, because it's not building the same vehicle over and over again anymore. We're going to build a new vehicle every couple of years with new technology involved. That's a complete change or a complete 180-degree turn from what we've done with ICE engines for the past 100 years. So how do we train all those employees? And you'll note that I need 50 folks right now. And as of our latest staff meeting across the entire industry in our facilities, we're looking at hiring 260 people, and that's all in Michigan. And those are mechanics, engineers, technologists, electrical wiring techs, and electricians. 2023, we're going up another 150 people. So between now and 2023, which is only a few months away, I need another 150 technicians on top of the 264 that I need today. And how do we train those people that fast? And that's the subject question, right? How do I get those people that fast? There's no current program that says I can train a person from no experience to a qualified electrical or EV technician in less than a year. So that wraps up what I had to present for you. I can answer any questions on what we have done, what interactions we've had, how we've utilized MNJTP as the backbone or the support structure for doing this. The entire program that we present today has taken us roughly 4.5 years to develop to get to the latest level. We're working on a couple of additional classes. We've developed one that's called microprocessors and microcontrollers. And this is going to help people with another one of the slides we saw previously today in coding and software. We're going to teach some C++ and C++ programming languages to allow some of our electrical and electronics techs the capability of doing some programming in these vehicles to help with integration. We're also running down the pathway. I saw fabrication on one of the slides previously today. There is no program out there that teaches fabrication as a whole, which is a combination of welding, sheet metal forming, and machining all in one person. I can go to some schools and get machining. I can go to other schools and get welding, but I can't get all three at any school. So we're working through the steps of a Department of Labor apprenticeship at this time to try and develop that and then bring that to one of the colleges to say this is what we need presented. So all that told, do I have any questions? Okay.
Hi, I'm just a regular ordinary person that lives in Macomb County, and I enjoy these presentations and everything. And okay, so my first question is, as far as your facility, I'm sure you have taught, you will teach your people how to do all the safety precautions as far as electricity goes. Have there been fires in there? Have you had to put out anything like actual fires?
We have not had any high voltage catastrophic events, we would call them.
Fantastic. Thank you so much. Also, is there any between the EVs and the autonomous cars? I know with the autonomous cars, there's laws that have to be developed. With the EVs, is there any laws that have to be developed at all as far as driving these cars?
So there are certainly things that are going to have to be developed as communities and as local government, because take this for instance, if I run out of gas and I pull off the side of the freeway, I can call a tow truck and he's going to bring me a gallon of gas and I can go to the next fuel station. There's no production ready solution for an electrified vehicle. If you run out of electricity on the side of the road, you're stuck. And you're going to get towed up on a wrecker to get taken to a charge station. Now, there are manufacturers, OEMs, tier ones that are all working on what we call remote charge stations. But the trick here is essentially it's going to be powered by an ICE engine to get the electrified unit there to charge the vehicle that's on the side of the road. So there has to be a better solution to that. We don't want to continue the ICE engine development for charging vehicles if we're trying to get away from ICE engine powered vehicles. So certainly governments are going to have to help with not only the installation of the charging stations that we talked about earlier, but strengthening the infrastructure that's going to power those charging stations as well as maintain them, and then have a solution for a wrecker company that can go to a vehicle and help. One other regulation I think I would throw out is that talking through the charging stations that exist today that pop up on your screen and they navigate you right to them. You get there and your plug-in doesn't fit that charge station. We need a standard charge station plug-in, right? Similar to what happened with OBD2 in 1980s, right? We came up with a standard. That connector is the same in every vehicle so to date. We need the same thing for electrical charge stations.
Okay, I'll give you one more. Okay, so you have your plants, and is there any, like, as far as, you know, we're all into environmental safety, environmental cleanliness and everything. Around your plant, is there any emissions of electricity or any kind of things around your plant that would endanger the environment?
There's no difference in whether I have an electrified vehicle or a gas-operated vehicle. Think of it this way. If I had a Duracell battery and I threw that in the back seat of the vehicle, as long as nothing affects that battery, it just sits there dormant. If a vehicle is sitting in a parking lot and nothing affects that vehicle, it just sits there dormant, just like the battery in your back seat. So essentially, around these plants and the things that are happening outside of them, no inherent danger that I'm aware of. Now, inside the plants, of course, there's regulation on chemical controls and emission controls and vapor controls and all these different things because of the chemicals that are being used in those plants. But again, that's not really any different than what happens in an assembly plant today.
Okay, so nobody's gotten sick.
Not that I'm aware of,
All right.
and certainly nobody within Roush, no.
All right, thank you very much.
You're welcome.
Thank you. I have a couple of questions. Your organization is basically a prototype organization?
Yes.
Okay. I'm from Massachusetts, and we're not known for manufacturing automobiles, obviously. But my main reason for being here today is post-purchase of the automobile. The diagnostic analysis, maintenance, servicing, post-purchase. Have you looked into that portion of the AV distribution or sales aspects?
So technically, it's not the prototype manufacturer's job to look into those things.
Okay.
But I'll elaborate a little bit on what we do know. What we do know is that there's a difference between interacting with the current today vehicle than there is interacting with an EV or an AV vehicle of the future. Right now, I can plug in with a standard connector that's been standard since the 1980s and 90s. And today's AV and EV development vehicles, some have that connector, some don't have that connector. So there's a difference in interface. I can tell you that every EV and every AV is going to require a laptop to plug into it. You won't be able to plug into it with a standard scan tool that you can go to O'Reilly's and get your codes pulled with. That's going to evaporate. Continuing on from there, though, as far as the maintenance, it's going to be education of those incumbent employees that are already out there. Anybody that has an electrical understanding of low voltage vehicles can be trained to do extended low voltage as well as high voltage vehicle diagnostics. And we prove that. We've got several hundred technicians that we've run through our training. And granted, it's a very simplistic training. It demonstrates what these systems look like and how to interact with them. And our folks have been very successful with the diagnostics of those systems.
Based on your experience, can a person within, say, 12 months with no ICE experience, within 12 months become a technician?
So we've actually done a lot of work with local high schools and employed work-based learning, WEBL. We take students out of their high school environment and put them into a shop environment. Now, there are plenty of regulations around what I can allow them to do and what I can't allow them to do. But a lot of these technicians at the end of a calendar year of school are comfortable enough to work with a vehicle to build a wiring harness, a simplistic wiring harness, and to do some low-level diagnostics. So I think the answer to the question is yes, we can educate those folks. But to your point, inside of a calendar year, there aren't many programs that are going to provide that education in 12 months. Most programs out there are going to provide that education in 2 years to 4 years. And that's where we need to get to. We need to squeeze that down. Yeah. And get that time frame cut down, because the need's now, not in 2 or 4 years.
I agree. I think it's absolutely essential. Thank you.
I'd like to continue that thought that you just brought up there. I notice in workforce development that there's a lot of focus being put on training a 3rd grader through 8th grader in mechatronics, computer sciences, and things of that nature. And the whole goal of that training at such a young audience is to get them to enroll in a 4-year university to get a 4-year degree. And the high achievers are now allowed to not go to college and enter into a skilled trades type of work environment. And what you just described, the Roush training is essentially a university or college level training that people have, with hopefully the aspiration of getting industry recognized credentials such as a degree or a certificate of accomplishment. Can you touch a little bit about what type of credentials people will walk away with that makes them employable by not only Roush but other organizations, maybe in the defense or aerospace or other emerging industries?
Yes. So what we've really targeted, because we're an automotive company, we've really relied on the ASE system and the master technician. Through the first 2 classes that we run, which would take roughly 80 hours of education or presentation time, an employee is really prepared to go take the ASE electrical test. And more than half of those folks, if they've paid attention in that 80 hours, are going to pass that test. With an additional 6 months to a year of experience through our shops and interaction with engineering on a daily basis, instruction, following work instruction, understanding the systems they're working with, they could easily go and complete college level courses. So they're essentially being prepared to go take the classes if that's the person that they are. Not every person is meant to go to college. Not everybody can sit in a classroom. And those are the people that we need to get that education to faster so that we can support the industry while other folks that are college bound can make their way through school and use that time, that 2 to 4 years, to come back with a degree. Continuing to use the IPC standards that are out there. That's an industry recognized, if it's electronics or aerospace, even NASA recognizes the IPC standard that we present within our shops. So to say that we're going to build that stackable credential, we have several that we can leverage and offer to our employees, and they could continue their work experience with us, or they could take that elsewhere. We hope they'll stay with us, though.
So I got a question for you. Since we are technically neighbors, and you're in Plymouth, I'm in Plymouth, for high school students, I know I've had a number of high school students go to Roush and get employment there. Some stay, some don't, of course. What are like the requirements that you all are looking for so I can kind of guide them that way? And then the second question is, you said about fabrication. I know my program, the repair side and the body shop side, our other instructor, we are incorporating that now into ours. We're not going to be able to go in depth on it, but what are you actually looking for when it comes to design, fabrication, welding at a high school level that would be acceptable for possibly getting a student from our district, our programs into Roush?
I'll go very simplistic for the first answer to that question. We look for sparkle in the eye. If somebody's excited to do what we're presenting, we'll take them. And that's the reality of it. If somebody's excited to do what we want them to do, we'll bring them in. We'll put as much time into it as we need to train them to do what we need. Now, the secondary thing is, if I'm looking at a student that sits in front of me, I'm going to ask them for a resume. And I guide them on what I want to see on their resume. I want to know what you do in your free time. I want to know if grandpa or dad taught you how to do a tune-up on the lawnmower. Have you helped put an outlet in your bedroom? And, all these different simplistic little things that kids and parents do together all the time. It's something that they don't recognize that they should advertise to an employer. And again, not all employers are going to recognize those things. But if I'm looking at somebody that I already know has zero experience in what I need them to do, what leads them in the direction of what I need them to do? So we look at those kind of aspects of their life and how do I incorporate that into building the next generation of technicians. And as far as fabrication, what we're looking for there, they have to be hands-on, right? And a lot of what we encounter today is people want to work to a flexible schedule. Well, unfortunately, we have a start time. We start at 6, and our time goes through to 2:30, 2:45 every day. So I can't flex a schedule for somebody that's going to build something physically in our shop, right? So it's the soft skills. We have to prepare this next generation that says there are going to be hard start times and there are going to be hard stop times. And you have to be on time. You have to present yourself as a professional, right? All these different aspects. And soft skills sparkle in the eye and want to, right? We can't force anybody to take an education. If they want it, we'll give it to them.
I got a question for about does Roush have anything to do with safety training? In regards to safety, I mean like first responders and arc flash type training for, you know, outside of technicians. So
we basically with our engineering teams developed an HV battery safety class. It's a 2-hour computer-based learning, or can be done in person. We have presented that outside of Roush, just to provide a familiarity to people at proving grounds and folks that are not technicians. You don't have to be a technician to understand the high voltage risks and how to mitigate those risks. So can it be presented outside of Roush? It can. Can I say that I provide you with a certificate that says you passed the Roush class? Well, it's only as valuable as the paper it's written on, because I'm telling you that I presented you the information. How much you understood it, I can't measure. So essentially, we've provided ourselves with training internally. We rely on a lot of the suppliers of these battery systems and integrated systems that come in to help us understand the safety aspects as well. Yes, sir.
Yeah, you work with all the manufacturers. What can you tell us about what the manufacturers are doing to bring new people into the industry as technicians for both ICE and electric vehicles? And is there a difference between what the companies are doing, what the legacy manufacturers are doing, compared to the newcomers, the Rivians and the Lucids and those? Do you know anything about if they have training programs?
That's an interesting question, and I'd love to expand on that, but I don't know that we're going to have enough time to cover everything I've got in my head on that. Where I'll go, though, is that the OEM manufacturers are having the same struggle as everyone else to find technicians. And where they're finding their solutions is they're going to the tier 1 suppliers and saying, hey, can I take inside 5 of your technicians? Can I take and contract 5 of your engineers? And they take them internal and work them as contractors to those OEMs. So it further just pushes the requirements to build these new technicians and engineers and all this workforce. It pushes it down to the next level. Now, there are some programs internally to the OEMs that they're pursuing their own systems as well. Some are providing their own classes to educate their people, as well as new incoming employees and mentorships, so that we've got these, I'll call them light level apprenticeships. Maybe they're not Department of Labor recognized, but they're operational within those systems, and they're providing those new employees with that tribal knowledge, the knowledge that's in somebody's head that's not in a book anywhere.
I want all the manufacturers to help us with the schools, work with the schools, with the young kids. Can you help us get them to do that?
If you can help me build the classes and a certificate program that's available in 6 months, Roush will do anything we can to help.
Electrical and mechanical engineering.
Yeah.
He'll graduate in 3 years. What are your benefit programs? I'd like to send him to you guys. He's at Ford right now. I'd like to send him to you guys.
So I'll say that our benefits program rivals all of the OEMs, and in some instances is better than theirs.
Okay, great. Thank you. Use the resume in 3 years.
I'll give you my email. Thank you.
That was great. Thank you very much.